Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to half subtractor. So here we'll discuss the implementation of half subtractor using NOR universal gates. Okay, so we discussed for NAND gate, now we'll discuss it with NOR gate. So first, some basic Boolean algebra laws which we'll use. So first, the De Morgan's theorem, x and y whole complement will be x complement or y complement. Second one, x or y, it's x or y whole complement is x complement and y complement. Then x and x, it will be the same. Then x or x is the same. So basically a variable which is ANDed with itself, it results in the same variable. With a variable which is ORed with itself, it results in the same. And the double complement of a variable, it results in the same. So these 5 basic Boolean algebra laws and simplification technique. So here there is no need of any simplification because it will be a very short expression. It is difference and borrow. So now the block diagram of half subtractor. 2 inputs A, B, minuend and subtrahend, and 2 outputs difference and borrow. Difference is A bar B or A B bar, and borrow is A bar and B. This. So first we'll take the difference. So we have to convert it into a format which is suitable for NOR implementation. Okay. A bar and B, A and B bar. This is difference. So if we double complement it, it will result in the same. So it will be the double complement of this. So here first we will apply the De Morgan's theorem to the lower portion, the inner lower portion. So it will be A bar and B whole complement and A B bar whole complement. So this OR is converted into AND. Then for these individual whole complements here and here, we'll apply De Morgan's theorem separately, which is A double bar or B complement and A complement or B double bar. Okay, this here. These are separate whole complements. These two terms we converted into this AND into OR. Okay, this, and then we have a complement above. Now we know that double complement of a variable, it results in the same. So A double complement is the same as A, B double complement is the same as B. So now what we'll do, we'll apply De Morgan's theorem to this. There is a complement and there is a AND. So this AND will be converted into OR and will have everything in OR form. So it is A or B bar whole complement or A bar or B whole bar or whole complement. This is the resultant expression of difference. Okay, and for the borrow output is A bar B. So if we double complement it, we'll have A double complement or B bar whole complement. So it is A or B bar whole complement. This is the borrow. So everything is in OR form and complement. So whenever you are implementing something using NOR gates, NOR universal gates, your objective should be that everything should be in plus format, in sum format, OR format. Okay, plus, everywhere it is plus. The variables are something plus something and then a whole complement. Okay, so complement and plus. So it is there everywhere, it is there. So now it can be easily implemented using NOR universal gates. Okay, so first, so NOR gate, if you remember, its basic representation is something like this: two inputs, OR gate followed by a NOT gate. So it is represented as a OR with a bubble. So if X and Y are the two inputs, so it is X plus Y or X or Y whole complement. So here what we'll do, first we'll take A input line and then apply in this manner to get A bar. A plus A is A, so A plus A whole complement, that is A complement. Similarly, we'll take B input line, apply it in this manner to get B complement. So we have got A complement and B complement. Now we need here, let's lower it a bit. So A plus B bar whole bar. Okay, so what we'll do, we'll take so A plus B bar whole bar. So this is A plus means OR B bar whole bar, this. Okay, next we have A bar or B whole bar. So A bar or B. A bar or B whole bar. Okay, now we need this, we have to add them together without the complement. So we'll see how we'll do this. First we'll take them and apply them to a NOR gate. So we'll have A bar or B whole complement or A plus or B bar whole complement, and then whole complement of the entire thing. Now if we again apply it in this manner through another NOR gate, this upper complement will be removed because double complement, let's this whole thing be like this. let it be x bar, where this entire thing is x, that is a bar plus b whole bar plus a plus b bar whole bar, that is x. So this is x bar. So when we apply it through another NOR gate, it gets double complement. This one is x double bar, which is equal to x, which means it is equal to a bar or b whole bar or a or b bar whole bar, this. So we have got it, okay, through NOR implementation, NOR gate implementation. Now the borrow output is a plus b bar whole complement. So here we have got it, a plus b bar whole complement, it is already there here, a plus b bar whole complement. So this is the borrow output and this one is the difference. It's not responding. Okay, this is the difference. So here we have got the borrow, here we have got the difference. Okay, so this is implementation of half subtractor using NOR universal gate. Okay.